So we're going to talk through several properties of addition. So we're going to start with the additive property of zero. This is sometimes referred to as the additive identity. This property is just the property that you guys already know. We're just putting a name to it. It describes what happens when I add with zero, right? So when you add zero to any number or you add any number to zero, you just get that number back. So in symbols, we could say for any number A, so A just represents any number. We could add zero to that, and that would still just give us A, or we could add zero to A. It doesn't matter the order we do that. And again, we just get A. So what's 4 plus 0? 4. What's 0 plus 18? 18. So then we have the closure property of whole numbers. So this is just the one that says if we're talking about whole numbers, the sum of any two whole numbers is also a whole number, right? So in symbols, if we have two numbers, we'll just call them A and B, but they represent any whole numbers. Then we can say that adding them together, the answer or the sum of that is also a whole number. And you can think through several examples to convince yourself of that. We know that if I added together two whole numbers, I wouldn't expect to get a fraction, right? I'm not going to add 2 and 3 together to get 1/3. I wouldn't expect to get a negative number from that, right? If I add two whole numbers are 0, 1, 2, 3, all the way to infinity, right? So if I add two whole numbers together, I wouldn't expect to get a negative number. I would expect to get a whole number. 2 plus 3 is 5. 2 and 3 were whole numbers, 5 is a whole number, right? 18 plus 20 is 38. 18 is a whole number, 20 is a whole number, the sum's a whole number. All right, so then the next one we're gonna move on to is the commutative property of addition. Make sure that you know how to spell this and how to say that. It is not commune. There's no N anywhere in that word, right? So it is the commutative property. And basically it says that you can change the order of the add-ins in an addition problem and the sum will be the same. So we're not going to necessarily say that it's the same addition problem. And this can be especially hard for children to believe, like in a story context, because the modeling is different. So for example, if I spent $5 on candy and then I went and spent $9 on ice cream, that's a different story than if I spent $9 on candy and then $5 on ice cream. So different problems, but they would give me an equivalent answer. The sum would be the same. So we can say for any numbers A and B, we know that A plus B will be equivalent or have an equivalent answer to if I did B plus A, right? We know 3 plus 4 is 7. We know 4 plus 3 is 7, right? So that's all this property does. We already know these properties. We're just making sure we know the names that go with them. And if it helps, if you think about like your morning commute, right? Commute means to travel, right? So if you're commuting to work, you're traveling. Basically our add-ins are traveling, right? So these A and B can travel. They can move, right? We can change the order. They can move around. So if that helps you remember that that's the name that goes with that property. Okay, so then there's a question here and it says, is there a commutative property for subtraction, right? And this is a tricky question. So if you were to Google this, you might get lots of different answers for this. So strictly speaking, no, subtraction is not commutative, right? Strictly speaking, 5 minus 7 is not going to give me the same answer as 7 minus 5, right? So no. However, we can still use it with subtraction if we basically redefine it as addition. If we're really careful with our subtraction symbol. So we're gonna say we can use it So we can use it for subtraction if we're very careful and keep the subtraction symbol with the number being subtracted. So for example, the subtraction problem, a minus b, right? Again, a and b could be any numbers. A minus b, you can think of that as being the same thing as a plus negative b, right? So if you think of it as addition of negative numbers, then it's addition, which means we can use the commutative property. Addition is commutative, right? So these properties we're going through are properties of addition. So we could move those two around and say that that's really the same thing as negative b plus a. So did it work to use the commutative property for a minus b? Yeah, as long as we kept the minus with the b, right? As long as so like we swapped those, we moved them around. It's just the negative or the minus sign had to stay with what it's originally doing. So that would work, right? So like if you think about a concrete example, like we said, like 7 minus 5, right? You could rewrite that as negative 5 plus 7, and that would give you the same answer. So 7 minus 5 is not the same thing as 5 minus 7, right? But if you keep the minus sign with what it's originally with, then that's okay. 7 minus 5 is 2, negative 5 plus 7 is also 2.